welcome to Self-Service AI with Power BI Desktop. Dzień dobry, I think that's the only Polish I can. So sorry for that, but hopefully you can enjoy my session anyway. So this is about AI, this is about Power BI Desktop, and this is about self-service. So we will not dive deep into what you can do in AI or machine learning. And I also, and of course, I want to thank all the sponsors: Future Processing, Infinite Data, KPMG, Objectivity, Summit, UBS, DB Watch, and Elite Mind for making this conference happen. Making it remotely does not make it easy for the organizers. So there's a lot of stuff going on in the background. So thank you for the sponsors supporting this event. Yeah, for my definition here for this talk, I took a very broad definition of artificial intelligence. So some features I will show maybe are not AI features, but they are smart features. And so I show you things which are automatical. That's a term I like here, because something is happening, is helping me. I don't really know how this is done. Is it machine learning? Is it AI? Is it like just if then else statements? Written by some developers, which are executed for me, to real machine learning things. So we will see things which are definitely machine learning, but some of the built-into features, features built into the Power BI Desktop might not be AI, even if they're can be conceived as smart features. And so I will show you things from the user interface. So we'll start with very easy stuff. We just click and drop and not type so much until the end, where we will write scripts in R and Python. So I try to cover a broad meaning and a broad set of features for Power BI Desktop. Yeah. So what are the smart features? When I started this talk, this list was quite short, and then features were added to the product. So on the one side, we have in the report, we can use the Q&A feature where we type in a question and Power BI comes up with an answer. And we have smart narrative, which drives this around, so it can sum up something I see on the current page and then sum it up in natural English language, what we can see here. There's the insights feature, which is like two things. There's one in Power BI Desktop, which we'll discuss today. There's also another insight feature in the service. Right at the moment, I'm not quite sure which one is called the insight. The other one is the smart insight or whatever. Microsoft does not have a very good job in naming things, but we will concentrate on Power BI Desktop here. Then we have this Analytic Line where we can add additional lines. We have the key influencer and the decomposition tree visual, which are built in visuals, standard visuals. We also have smart custom visuals, so you can reach out to the App Store to download additional visuals, which can help you discover something in your data. And that is what if parameter. Scripts, we can run things, of course, in DAX, which is the data analytic expressions. As soon as you need to do calculations on aggregations, there's no way around DAX measures. So learn DAX if you want to bring Power BI to the next level. And if you want to bring your machine learning reports on the next level, maybe you want to write scripts in R and Python, which can be run on the one hand in the report as a visual, but we also have this available in Power Query. So you can also in Power Query run scripts in R and Python. In the Power Query, we have this AI Insights feature. If you possess a premium per user or a premium capacity license, then you can reach out to some features here, which is just a wrap around to some features in cognitive services. And then everything, also the costs are covered by your premium license, or you can write on your own and connect to cognitive services, to Azure Machine Learning. There's also the smart features, column by example and web by example. If you have particular interest in one of the features, please let me know over. I hope there's a chat functionality or whatever. I didn't discover it by now, but somebody will let me know if there are questions, hopefully, and then we can dive into one particular feature, because in this talk I cannot cover all of them. So let's start with some of them, do a pre-selection for you. If you're particularly interested in something, please let me know. With that said, we dive into the demo, and I will not leave the demo a couple of minutes before the end of the session, which reminds me, is this a 50 or a 60-minute session? I come very bad prepared, obviously. 60 minutes we have, very good. Okay, so demo part. That means I have to go back, of course, here and then change to my Power BI file. So this is our normal Power BI file. I connected it to AdventureWorks from AdventureWorks database, downloaded something, and did prepare my model. Not a big thing, which I did here. And the first thing I always show people when I introduce Power BI Desktop is this Q&A feature. So Q&A, there's different ways of starting up Q&A. I find the easiest just to double click on the canvas. So I just not move, but click the mouse button 2 times, and then this visual here. And it says ask a question about your data. This is what I can do. It also comes prepared with some questions. I did not prepare those questions, so Power BI came up with that on its own. Obviously, it found out some interesting things like the top product categories by total product cost, or the top reseller sales promotions by total product cost. You can have more suggestions. You can even come up with your own suggestion for your end users. But the easiest is just to ignore those things and just start typing. So if I type in sales amount, then if I'm lucky, it will discover that sales amount is a measure in my model. So currently I'm curious why it's red underlined. So it should be 2 blue lines, which says, yes, I know what you're talking about. And now it showed me the sales amount. It took it from one of those tables I have here. So Python time series, blah, 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 sales amount, one of those tables. And I can also add more things. So maybe the total of the sales amount from a whole model for all the years, all the products is not so of much interest. Maybe I want to dissect this by category. It happens I have a product category in there, and it's smart enough to show me the product categories now as a bar chart because it's categorical data, right? It should not show this as a line chart or whatever. It's smart enough to discover like that. As long as I want to keep this thing open, I can. So I can always change the questions in here, or I can start over with another one. For example, I can ask as the sales amount by a promotion. And for the sales amount by promotion, I see there's like different promotions. And what I can do is also to ask for 2013. 2013, of course, is not the name of a table or a column in my model, but that's the content of the date tier or the date column. And Power BI is smart enough to discover that. Now I got a filter on 2013. When I convert this to a normal standard visual by clicking this nice button, I lose this input box. I cannot change the question anymore. But now I have a very normal visual, which I would have also be able to create on my own without the Q&A visual. So there's no difference in this visual compared to if I would have built it on my own. And as you can see in the filter section, we have now the date is in 2013. So there's a filter automatically applied by the Q&A feature. I could also right click here and maybe get rid of the exclude of the no discount because maybe I'm only interested in the certain discounts. Then it automatically will add another filter to exclude the no discount section here. Another thing we can do here is sales amount by I have a territory group should be this one, which is then geographic information. So North America, Europe, Africa, and Pacific Ocean. And I'm not a particularly big fan of those visualizations, especially for simple data like that, because North America, the people I talk with, they know where North America, Europe, or Africa lies. For some reason, it's not really Africa, it's NA, which is like not available, and for some reason it's put in like in Nairobi, and this is part of Africa. And the other thing which is really weird is that like the Pacific region, of course, is Australia, New Zealand, the Philippines, Japan. That would be the Pacific Ocean, the Pacific region, and not some point in the middle of the Pacific Ocean west of North America. So what I can do here is I can also ask, that's why I demonstrate this, as bar chart. So I can also ask for certain calculations for certain things which this tool can do for me. So I don't need to learn how Power BI as a tool works. I don't need to know anything about the visualization and the fields pane. I can just do this by type in. If I'm able to type in a keyboard, I can do a lot of things in here. And last but not least, it will be also lead to this time series analysis we can do, sales amount by date. Then again, the date is a continuous value, and therefore Power BI is smart enough to put this as a line chart on my screen. And let's keep this sales amount. So I'm go here again, sales amount by date. Let's see what we can do with this. So we can click half of the screen, demonstrate some things which we can do here. I have to convert this to a real visual, to a normal standard visual. And things I can do here is, for example, I can right click on my on data points here. For example, this is January. Maybe I'm interested why we have this huge spike here. So from 2.6 million to 4.2 million, almost doubled in this region. So maybe I'm interested, and what I can do is I can ask for analyze and explain the increase. So let's see what it's coming up with. Every time we see this light bulb, this is now machine learning applied. So this Power BI analyzes my model and tries to find out if it can find out anything in here. And maybe I know, I think I screwed this also up the last time I did this, because for some reason it does take everything from this Python series. This is my bad. I have sales amount in several tables just to demonstrate different ways of showing data. So this is not a perfect model, end user ready a perfect model, but I have to change this to the sales amount. I have also a sales amount in my measure section, and that's this one. Then let's try. Let's give me another try. And of course, the date is not from here, but it should be from the date table. So nothing bad with the Q&A visual, but for some reason I have the same things multiple, but still a little bit different. So let's see again if I analyze, explain the increase. Now what I get. Yes, that's what I would have expected. So now it's explaining here is the analysis of the 58.05 increase in sales amount between 1st December and 1st of January. So between 1 month of data, because we have monthly data here in this model. Even if it's the date, we only have monthly sales, so everything is moved to the 1st of the month. And then show this waterfall chart where you have the green things increase, red things decrease, total and other, and also summing up what is found. So sales amount by date and first name. So the first name of our employees, of our salespeople. It found some relationship here. So Ranjit, Linda, and Garrett, those here, Ranjit, Linda, and Garrett, I count for the majority of the increase among first name, offsetting the decrease of Shu. So we lost, or Shu had a decrease in sales. The relative contribution by Ranjit and Shu changed the most. Of course, this is not very helpful because, like, what would we do with this data? I think this is very important to talk also about that. Even with the smart features, Power BI is very agnostic about our data. It doesn't know anything about it. It just finds relationships, it finds correlations. That's what's showing up then. And we have to think about, is this useful? Can we do anything about that? So for example, I don't think it makes sense to hire more people with first name Ranjit to increase our sales. So there's no connection. On the other hand, there might be that we don't have just one Ranjit, but like 10 Ranjits. Of course, those 10 Ranjits sell more than one Garrett or 2 Linders. So we don't see that here. The third thing is, especially in Europe, I am hosted in Europe. Most of you are probably hosted in Europe. So GDPR is a huge thing. So we have to be careful if you're allowed to analyze the performance of individual employees over this. But why did Power BI come up with it? And this is because Q&A is looking at the whole model. And you already have seen, I screwed it up because I have the sales amount column also in here. So I'm like defeating the purpose of Q&A and defeating the purpose of having one simple model. I also have the employee table here, and I show the first name. So the easiest fix here is to just right click and hide this model. I hide this from the end user, from ourselves. So hide, then it's disappearing. It's not really deleted, it's still there. So if I have a report on based on the first name, it's still working. If I have a measure working with the first name, it's still working. It's just hidden. So I can even like right click here, ask for view hidden, and you will see there's a lot of columns there. All of them, a lot of tables and columns, all of them with this I crossed out, and still the first name is still there. Can I find it here? The first name is still there. So I could anytime I could unhide it again and show it to my end users. But I do not want to see the hidden thing here. If we again ask for please analyze and explain me the increase, now we get a different information because we hit the first thing here. Usually it's coming up with up to 8 different insights here. So some of them are useful, some not. Please be careful what you're seeing here. So for example, the next thing it came up for is by gender. Oh, very, very, very hot topic, right? So we're playing the gender game here. So obviously from December to January, the male salesperson, the increase in their females increased also, but way, 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 way less. And maybe you might think this is the reason because we have a lot of male employees, a lot of male salesperson. And of course, if there are more male salesperson than female salesperson, of course, their increase will be bigger on an average month. But Power BI and this feature is smart enough to discover this if it makes sense. Obviously, there is something behind this number. And if we change the visualization, maybe not to this portfolio, I never was able to find out why I could use this one. But the relative ones, the percentage, is very interesting because we can see now the females are green and the males are blue. And in December, it happened that the female salesperson are covered for more than 50%, while in January, they covered only for 30%. So something changed there. As mentioned, I'm not want to play any gender game here, but this could be an interesting insight. So you could then give the thumbs up. This is only going back to the product team to tell them there was something useful they discovered there. It's not changing the model, it's not changing the behavior in the product. And I can also add this. So if I press this plus button here, I can add this as a visual in here. And of course, this is a standard visual again. So we can change anything we want. For example, I can change the colors. Still struggling with the new visualization. It's really dumb. So columns, here we go. So the females, I'm old school females. I turn in red. And then we could add an analytic line here, a constant line, add a line. So we show a line at, where is it? Here, the line at 0.5. So now it's very clear that 50% is like right in the middle, and that the majority in January or in December was by the females, and this turned around for favor of the male salesperson. So that could be interesting. And what you can also see here, there's no need to show any pie charts. You can have 50% numbers or the majority even without pie charts. So I try to stay away from pie charts and do not try to overuse them. So let's make a little bit of space here. So I want to show you another, again, self-service feature. So we don't have to type anything. We don't have to know anything about machine learning, about R and Python, but we can use features like that. So for example, I can add another, no, this was the wrong thing. I want a smart narrative. And this is, I think, this one, smart narrative. If we click here, what's now doing is it's analyzing what's on the page and this up in plain English. So when in the Q&A visual we had to type a question in plain English and got the result, this is the other way around. We already have something on the page, and now the smart visual is summing up what we're seeing. So sales amount trended up, resulting in a 122% increase between 2011 and 2013. So from this point, which is 1.5, to this 3.4, this is more than double, 120% increase. Sales amount started trending up on Thursday, 1st November 2012. This should be something like that in here. It's a very low point and rose by almost 15% in 4 months, up to here. Then again, so this is ever increasing, and everything which is underlined in green, this is not hard-coded text. So if something changes in my data, if I, for example, apply a filter, let's just demonstrate this. Clear that I'm not lying to you. Yeah, I would lie to you. So I have a filter in here, and for example, have this for product categories. Or I've seen the product categories. Let's keep with similar things. The product categories. Put this here in a slicer, and then I want to see this for accessories. Then you will see, of course, this chart changes, but also this got updated. So for the accessories, the story is totally different, with an increase from January to November by 900%. So from this point where it was like only 3,000 to now 38,000 1,000. This is an increase by almost 1,000. So this is still interactive, and you can even edit this thing. So when we want to add something, so we can have things in here, edit. Can I do that? I think I can add a value in here, and then I can ask a question. For example, sales amount for bikes in 2022. So let's see if this works. Yes, there's a result in here, and then I name this bike sales 2022. Give it a name and save this. Now this is added here. Is it? When can I see it? I think it did not work. Let's give it another try. So let's add something here. Add value. Sales amount. Does this work? Sales amount should be from the 78. Still red underlines, I'm not sure. For bikes category, product category, yes. In 2022, of course, we don't have anything, but 2013, for example, that's the last day. So we don't give it a name, save some time here. Let's see if this works now. I'm not very lucky today. So it should show the number. Then I could add a text, for example, sales for bikes in 2013 was, and then I see this number is of course we're not seeing anything because I have a filter on accessories, right? So this doesn't make sense. If I remove, hopefully now we see the number. So okay, my bad, not the product is bad. The problem was between the keyboard and the chair. So you can add things here to like have your management summary, and not rewrite this every day or every month, but have this actual calculations applied. And you don't need to know DAX. You don't need to do anything in Power Query. Just type in the Q&A thing here. Any questions so far? I think there is more what I can show you here. But if there's any questions, please let me know. So again, have the sales amount, and still it's coming from the other table. I will create this differently. So remove this. Let's have a line chart. So there's the line chart, and then we put in the sales amount, which is the x-axis. I'm confused by that. This is the new naming here, and then there is this date. I want to have the date on the x-axis. And I don't need this nice calendar. I want the individual dates. What we also can edit, we already had seen this analytic line here. We did this for the 100% bar chart, a column chart. Depending on the visual, for example, here we have a line chart with much more. In the 100% line bar chart, the 100% column chart, we only had this constant line. Here we have different things. For example, I can have a trend line. I just click here, and Power BI is calculating a simple regression line. I know it because I also calculate the simple regression line, so it was the same thing. From the options, there's no clue how this is calculated, and you cannot change the formula. So if you needed a normal trend line, a simple trend line calculated as a simple regression line, you're good to go. If you need a more advanced thing, unfortunately, there's nothing you can change here. I will show you other things throughout this talk, or where we are more flexible, but then you have to do a little bit more things here. This is one way. Another thing which we can do here, instead of the trend line, we can have a forecast enabled here. Again, the forecast doesn't offer many things. For example, we can ask for only 6 points, and maybe we already know that the seasonality is about 12 data points because this is month, and then I can apply this, and maybe it will change a little bit. But this is it. Rather easy to apply, but not very flexible if you need more. So if you are a data scientist, or you don't know something about R and Python, this will maybe not fulfill what you want to do. But there's a better solution later, which I will demonstrate later. Let's see what this if this makes sense or not. So this forecast, like we have this like very volatile line, right? And then the forecast it also continues to be very volatile. Is this correct or not? Nobody knows, because this is a prediction into the future, and predictions are very hard, especially if they are according to the future, right? So if you think about how this is calculated, maybe we find out if this makes sense. So usually time series forecasts are done by analyzing and finding patterns in the time series in the past. And if you look at the shape of what we are having here, it's like a shaped pattern. So I think I can turn off this. Where is it? I can turn off my in here, general, a tooltip. Let's turn off the tooltip. So we can see here this M-shaped pattern, and my first name is Markus, right? So I'm eager to see, or it's easy for me to discover M-shaped patterns. And we also have an M-shaped pattern here, and we have another M-shaped pattern over there. And this is what the algorithm discovered. So we have one starting in November here, another one in November here, and another one in November here. So it discovered this pattern, made more or less an average over that to find the seasonality. And then it also found out that there's an upwards trend, right? We just have seen this line, this trend line going upwards. So this M is of course on a lower level than this M, and of course the prediction, which assumes that everything stays more or less the same. It's also then predicted for the future, an M-shaped pattern for the future. The gray area here is the confidence interval. So this means, in my case, I turned on the confidence interval to 95%. So with a 95% probability, the true value will be within this area. And as you can see, because it's so volatile, of course, this confidence interval is also rather big. So it could be anywhere between here or here with a 95% of change. If I decrease this, then the gray area also gets lower, but of course then the confidence is not as high. And if I apply this, we also should see that this gray band decreases in size. Anything else I want to add here? And another thing for instead of the forecast, this was last year, was this find anomalies. So anomalies are, or the way this is calculated here is more or less to think about what is an anomaly. An anomaly is something which diverges from what we would have expected. What would we have expected? But that's easy to find out, because we can just apply a time series prediction, time series forecast, but not to the future, but to the known data. And if there's a certain difference between my prediction and the confidence interval and the actual value, then it would be unexpected, and then we would conceive this as an anomaly. So for the current numbers, for a sensitivity of 70%, everything would be fine. The higher I make this value, the narrower gets this gray area. So this is the other way around. I have to apply this constantly. And sooner or later, we will come to a point where some of the actual data point is out of this gray area. And this will be then shown as an anomaly. So there should be an anomaly. But there, I have really bad luck today. Why doesn't... Should point out this is an anomaly. It does not, for some reason. As we can see here, the gray area is outside of this area, but still it's not showing the anomaly. Find anomalies, and the anomaly, anything here, size, expected range. Yeah, there's only the coloring here. So I fail. I failed also for the other demo and found the reason. I'm not sure if I can find the reason here, because if you click here, of course, no explanation comes up for the anomaly because it's not conceived as an anomaly. Okay, try this out. Very, very simple to do. Again, we only have very less options, which makes it easy to handle, but on the other hand, not very flexible. So what's your solution if you need more flexibility? This next step, I would suppose, would be to reach out to custom visuals. So in the visualization pane, you have this ... at the very end of the standard visuals, and from there you can get more visuals. So there's a plentiful, a huge range of other visuals available. Some of them, or most of them, are free. Some of them you have to pay for. Most of them just put up there. Some of them have this blue icon here. This blue icon means it's Power BI certified. That means that somebody at Microsoft took a look on the code to confirm that the code is safe. So there's no way that the data is then like exposed to somebody else. Because if you download this visual, please be aware of that you're more or less installing a program, a piece of code inside of Power BI Desktop. So if you use this visual, then some developed code is executed, which was developed not by Microsoft, but by some third party. So potentially, didn't hear anybody about that, that it really happened, but potentially that could be like careful or dangerous code. With this certified by Power BI, you can be sure that somebody at Microsoft took a look on that. So if you have really sensitive data, please restrict yourself to this certified things. And for example, if you want to see a time series prediction, then we find some visuals. Say some of them already downloaded here, so I don't need to download them here. As you can see here, forecast, TPA, TS, clustering, and so on and so forth. So I downloaded some of those available things. And if we take a look on the forecast with ARIMA, this one, same data. So it's the same data we already worked with. So we have again the date and the sales amount, always the same thing. And for okay. So I just got I became uncle today, and now my wife got me a note about the name of my nephew. So very good. So here we see the ARIMA, which is the average roll. What is it? I never can remember this. That's something of moving average, and it's like automatic. Yeah, you can look up this. It is one of those algorithms, very favorite algorithms for time series prediction. And as you can see, again, the green line is what the actual data is, and then there's a calculation here. This is a visual, so this is nothing to do with my analytics pane here, but this is something the visual offers. So for this, we have, for example, forecasting settings. We could change the forecasting length. We can change the confidence interval, so the purplish and the gray area here. We can help this algorithm to find out about the seasonality or just keep the automatic one. We can customize the model, so set maximal values for P, D, and Q, which are the parameters for the ARIMA, where you can drive and influence the calculation. So we have plenty of options here, which we could not do with the analytics section up there. And you can even, like, if you already know what values work best for your prediction, you can also just set those values. That's what I did here. So we get again an M-shaped pattern. This M-shaped pattern is a little bit different to what we saw in the with the automatic forecast, because the algorithm is a little bit different. There's a way to find out which one is better or not, doing these predictions, storing those values, and then you can compare them. So for my employer where I worked, we did this time series predictions for the most important numbers, for the most important KPIs, like every day for the next, I can't remember, was it 180 or even 1 year, and we did this every single day. So for 1 point on a day, we would have like the actual value, and we would have like 180 predictions for this date. So we could also see how good this algorithm was before and after we tuned it, before and after something special happened in our data. So you can really learn about about the algorithm and also about how your business works, always assuming that there's no huge impact, yeah? Because if like the trend shifts because there's a war or whatever, there's a pandemic, yeah, then of course your predictions might be on the wrong side. If this is not good enough for you because you need more choice of algorithms, of course there's plenty of other custom visualizations, or you could reach out to write your own code. So for example, in this forecast example, is it here? Yes, I have again my standard visual. This is what we already talked about. I have forecast turned on for the next 6 days with seasonality and the confidence. Same number, the same chart we already have seen. It's just a little bit squeezed. Always be careful if you change the size of a line chart, because if you squeeze it, then sometimes the trend looks rather flat. If you like stretch it, then the trend looks more extreme. So be careful with that. And I took the same numbers and applied it to algorithms I wrote in R and in Python. So it's the same. The green line is exactly the same thing. For some reason here we have a difference again, so I have to check out what I'm doing here. But this should be the same numbers. Maybe it's not cut off here, started here. Yeah, and the prediction is almost the same. So we see 2 times this M-shaped pattern, more or less this M-shaped pattern. So how do we start Visual or in Python Visual? On the visualization pane, this is standard visual, R script visual. And if you open up an R script visual, you will get this very nice editor down there with the first 6 lines, which telling you the following code to create a data frame and remove duplicated rows is always executed and acts as a preamble for your script. And then it's, again, this is out commented, but it's telling me it's creating a data set. So this is the language of R. It's creating a data set. Left assign something from the right. And here it build a data frame. Data.frame is a function name, which builds a data frame from the date and sales amount. Why from date and sales amount? Because this is the columns I'm having here, date and sales amount. And then it would be get rid of all the duplicates by applying the unique function onto this data set and applying the result set against two data set. I'm not sure if it's really executing this code, but this code represents what Power BI doing, because this is the normal thing Power BI does, right? If you have some dimensional value, like a product category, and then put in a measure, it will not repeat the same category name more times, only show it once, unique category name, and sum up the values for this category. And this is what it always does, and this is also what it's doing when it's exposing data to R. And the rest, for example, in R, like out here in this comments here. So I load packages I will use. I prepare a data set. I then create a model, and then I return and the plot. So I plot something which is then shown as the visualization here. So let's talk a deeper look here. So for R, if you never heard about R, the good thing with R is that there's plenty of packages. So R is open source, and there's a lot of people contributing to Power BI, to R. So I love the Power BI community. I'm an active part of that. I'm organizing also conferences and user groups meetings in Austria. But the R community could be even better. So they're really active. And I think I looked it up, like in beginning this year, there were like 14,000 packages, or 15,000 packages. Tremendous numbers of packages you can just download and use for free. And the good thing is, this is not just rubbish packages, so don't be impressed by the number of packages, but this is academics, universities, really smart people working on those packages. So if they discover something very useful to either handle your data or having a better algorithm to time series prediction or whatever, there's a good chance that this university or those smart people also implement an R package for that. And then you can just download and use it. Like people like me, I'm not a data scientist. I would not be able to write a package, but can easily use it. For some reason, this is open source and there's no standard. So that might be the reason why there's like funny names for things. There's like a package called Zoo, which helps me in, I think this is used for the date time conversion. There's a forecast, which makes it easy. Yeah, forecast, we're doing a forecast, so this is a useful name. Dplyr is also to clean up the data frames, to work with data frames. ggplot2 is the successor of ggplot. It's the grammar of graphics plotting way, and it's a really cool package to actually plot those things. And the scales package I use to get these real numbers in there, because R is coming from, or it's a successor of package S, which is for statistics and for mathematicians, and they usually write or use the scientific notation. So 2 million would be 2E02, or O6, sorry. So 2 to the potential of times 10 to the potential of 6 zeros. That's how the scientists write numbers. Business users don't like that. That's why I'm using the scales package here to show real numbers, as I usually say. So then I prepare this. So the only thing I prepare here is very little, because usually I use Power Query to prepare my data, because it's much easier to click around in Power Query or to copy and paste than the M script, as I think, than writing an R script. But what I'm doing here is I'm converting the date format from the date I receive from Power BI to a POSIX format, POSIX CT format, because it's easier to handle them in the other packages. Most of the packages expect the data to be in this POSIX format. That's what I'm doing here. Then I create a model. So M is then my model, it's a variable for my model, and I call the ARIMA function. The ARIMA function is part of the forecast package, and then I pass in my parameters. Remember this order and seasonal 0, 1, 1. This is also something we could set the P, Q, and R value for the package. If I have this model, so it's model, I'm training the model, and no, I'm creating the model, then I'm creating and training the model with that, and then I do the prediction using my model to predict about the six next numbers, and that's what I add then to the data frame. So I build another data frame where I combine my existing data, which is the sales amount, plus the predicted value. So I have both the green line for the actual value and the blue line for the predicted value. That's what I'm merging here then with this merge package. Then I create this plot. So ggplot is from the ggplot pack. I plot my data set. Remember, that's what's containing all my data. And for the aesthetics, I use the date on the x values. Can you read that? I can zoom in here. A little bit slow. And with that idea, then on the y value, I put in the sales amount. As I have a sales amount, a blank in the name, I have to use this get function here to reach out to the variable name sales name. For the geom line, I use the third color. You could also use names here. For some reason, I started using those numbers here as a line and a point. So I want to get a point and connection between those points as a line. The text should be in the size of 18. I fix the scale of the y-axis to values between 0 and 6 million. So if some filters are applied and so on, I do not want to like move the line apart and change the axis. I want to fix the axis on these numbers. And then I add another thing, the geom line, for the prediction. So in a different color. That's the blue thing at the very end. No legend. And then I have to say labels, date and sales amount. That's what you get here. And in Python, the story is very similar. It's a different script, of course, because it's Python. We also have some packages there. Again, prepare a data set to make the numbers and the date working good with my with the packages I use here in Python. Then I again create a model. In this case, it's again at the ARIMA algorithm, SARIMA X. Create a forecast and then plot the thing with the standard plot functionality here, and I end up a similar plot here. Similar because the numbers are a little bit different. So because the numbers are different, of course, also the algorithm is different because the implementation of the ARIMA will be different, a little bit different than in R. Then of course we get different numbers here. Any questions up to this point? Very interesting on this part is also to find out about this forecasts is to jump over to the time series decomposition. So this helped me tremendously in understanding how this forecast happens, how a forecast could happen and how this works and how it makes sense or not make sense. I think we already discussed this a little bit, that I told you that it's like patterns and applying the pattern to the future and also taking care of the trend, and that's what we're seeing here. So I have a standard visual on R data, so we'll take a look later on the Power Query. So because let's jump back here to this one. So in this case, I have an R script visual. That means every time this report page is refreshed, the whole script is run, which is good because if I apply filters, if the data changes, this script has a different version of my data, and of course the prediction will be different. Everything is fine. The disadvantage here is that every time the script runs, and maybe the data cannot change that much. So maybe it's enough to load or do the prediction when I load the data through Power Query, and that's why I could also run the R script in Power Query. We'll see about that later. So what I'm doing here is I use the data I got from the R script running in Power Query and did show it with the standard visual. This is a standard visual from Power BI. So even like R is involved here. It's not involved as a visual. This is just this area or stacked area chart, but it's not, an R script is not running here at this point. And where it's running is down there for this decomposition tree, decomposition of the numbers. And let's make this small again. Remove this. So this, at least for me, this helped me to understand the thing. So what we'll see here, this line chart, that's the actual numbers. That's the volatile numbers we have over all these years. What they discovered was that there was a trend over the years. So there was a very unstable thing here, maybe going down again. But from this point on, we have an upwards trend. That's what it found out about the data. And as you can see, the algorithm for Python is a little bit different. It's the same data, but the algorithm is a little bit different. So we don't know what the truth is. The truth depends on the algorithm you apply. And then they find out two other things. So the trend is okay, and the other thing is the seasonality. So it found out that like the pattern is always the same. As we can see, this M-shaped pattern is exactly the same here and here, because that's what if you deduct from the actual numbers the trend and apply the pattern again. So this is without the trend. And we have the same thing with the Python thing here. Again, the M-shaped pattern here, exactly the same thing, exactly the same pattern, because all the trend was taken away, and there's also some rest then, because if I apply the same pattern here and here, but of course the actual numbers are not exactly the same. Even if I take care of remove the trend, it's not exactly the same. So this is the thing which is like random or cannot be explained, or here it's like the residual, so that's the error of the prediction. So if I apply the prediction to the past, I would be off by these data points or off by this line chart. This is the price we have to pay to get a prediction. That's why the prediction will be never spot on. I mean, if the prediction is spot on, I would be very doubtful. There's something wrong. I would be curious about why it's spot on, because this is very unnatural that it would be spot on. So this can also help us, and this is also something which we can then show to our end users, so they understand what's happening here, so they can better perceive and make the prediction more useful for them if they really understand what's happening there. Instead of just showing a number and they trust or do not trust the number. So let's take a look on Power Query. So if we jump over here, this is Power Query. I guess you're familiar with that. So this is Power Query. And in Power Query, I have different sections here. For example, I have my actual numbers, and I have, for example, this R integration. Let's concentrate on R here for the first thing. Make this a little bit smaller so we don't need it, not distracting us. So we have this R things, and I applied R scripts in Power Query. The difference here is that when I apply the script, when I load it, the script only runs when I load it. So the result of the script is then persisted in the data model in Power BI. So next time I want to show the prediction, it's very fast because no R script is running. And it's not because the R script is so slow, but also because the R script is like coming up with a model. It's training a model, it's applying the model, and then showing something. And I could like push this time and effort to Power Query. I could even push this further to the database in SQL Server, and in Azure SQL you can run R scripts in R, Python, and Java natively on your database, and also do during the ETL persist the data. That's what we did in the other project. But like the easy thing here, yeah, I've edit the permissions because this is an R script running, and of course I have to allow it to run it there. And then again I fail here. What's the matter here? Because the source. So this is because it's a different folder, I think. Is it? Oh, I forgot it. So my folder here is called, oh, I can't find it here. C uses, it should be, yeah, Ehrenmüller. So I changed this recently. So the permission, run, and then we should be able to see this. Still not because Ehrenmüller, this is right. No such directory or file. Can we find something else here? Okay, just ignore the other thing. So for the trend line, the source here, that's the reseller sales. So I took this from the database, and then I removed the other columns because I only want to trade on my trend, the sales amount and date. Then I renamed the columns to make sure that that is the date, and the sales amount is sales blank amount, because that's what my script already expected. I could also rename it in the script, but I had the script at hand and I wanted to prepare everything in Power Query to make the script happy. So I didn't have to change anything here. The grouping is then necessary, so I get one sale per date because I want to have everything on the 1st of the month. I want to do monthly predictions. And if something would be like, because it's AdventureWorks, right? Here there's like some sales are on the 1st and the other sales on the 13th and others, but there's not a sale every day. So a daily forecast would be useless because you put like a lot of empty points in the data. Then I change the data type here to what I'm doing here to a number, to a whole number, and then I run this R script. So if I open this this little here, we see this R script, and this is the same script you just have seen during the other demo. Maybe it's not exactly the same here because here I'm doing a linear regression, not the ARIMA. ARIMA is the other one. You can also take a look there. Again, I prepare my data by converting it to the POSIX format. Then I'm applying not the ARIMA algorithm here, but the LM algorithm, which is a linear model, a linear regression model, which is part of the standard package, so I didn't have to load any additional libraries. And then I create an output. So the communication between Power Query and the R script is that I get one thing, like the last query, the last result, the last step is the content which comes into the R script in the form of this data set. So there's a data frame called data set, which you can use here. And then I can create as many data sets as I want in this script, and all of those data sets are then get listed here. So in this case, I only have one output data set, which is a cbind of the current data set, so the data set I received into the script, plus the prediction from my model. So that's what I added here. So this new thing has now the same columns like the data set I really already had, plus an additional column called prediction. This is what we see in this output here. And you can see here the output. Then click on the table with the date and the sales amount. This is the same thing I received, but yeah. All I can now use only during the refresh. The disadvantage is this number will not change. So if I apply any filter to my visual, the visual will not change. The result of this prediction will not change. I can demonstrate this if you jump back here, and we have these two trends. So what we're seeing here, this is the R script, which is on the fly creating this trend line, right? With the ggplot, and then I have this start smooth. That's the change to everything else we already have seen. And here I use ggplot, not an extra linear model, but I use the functionality of ggplot to show this linear model. And I don't need the standard error. I don't need this confidence interval. So no ribbon here. And if I calculate this calculation is done on the data exposed to the script. And that's why I see this downwards trend, because over these numbers we're seeing here, we have a downwards trend. For the same data in here, I don't see a downwards trend. I see a stable upwards trend. It's the same number. What's the difference? In here, I'm using, again, a R script, but in this case, I'm not doing the start smooth here. I'm not calculating anything, but I use the over-predicted number. Here we have it, the GM9, the prediction column from what we just have seen in Power Query, which is calculated on the whole data available for the R script during the refresh. So that's a very important difference to understand. That if I change these filters here, that of course then the line chart or the trend line will change for my left chart. Big numbers change, of course, that all those numbers change, but the other one will never change. It's always the same. And this is also a funny thing. I think it's called the Simpson effect, because like over the whole time series, as you can see, we have an up from the beginning of time to the end of time, the data available here, we have an upwards trend. But if I limit this to just one single year, and it's doesn't make any difference which year I'm limiting it. So I'm now not able to change anything here for some reason. I don't want to click in here. Can we change it like this? So if you move this up to 2013, 12, so 13, then we see within 2013 we have a downward trend. And that's called the Simpson effect. I think I heard about it at the beginning of the pandemic when somebody discussed that like numbers were going up and down. So in some reasons the numbers were going down, but overall the numbers were going up, which is counterintuitive. And this can also be demonstrated with these numbers here in AdventureWorks. So if you select just one certain region, like 1 year, then we have a downward trend for every year because we sell more in trend. We sell more at the beginning of the year than towards the end of the year, but over the years we sell more from 1 year to the other. This can be demonstrated here. So, and I think this is the time where I start to sum up my talk before I run out of time. So I hope you enjoyed this talk, and I tried to show you different things. So one thing, first thing at all, we concentrate on solely on self-service. So everything I demonstrated here, you can do in Power BI Desktop on your own. And remember, Power BI Desktop is free of charge. So you can download Power BI Desktop anytime on any machine. Microsoft will not ask you for any money for any license, and everything I demonstrated is possible with this free version of Power BI Desktop. So this is self-service. If you think for enterprises, maybe not everything I demonstrated here is good enough for an enterprise. I, as somebody who is responsible for enterprise BI, I do not want to have R scripts running in different visuals in different reports, because if we want to have new versions, if we have to correct something, we would have to correct it on different spaces, different places. As I'm not eager to do, I would try to push everything either to Power Query or to Power BI data flows or into your backend database. So keep this in mind. But what I have shown, I have one slide for all of the features, even if we did not talk about the feature. So the first one was the Q&A feature, where you can type in a question in literal language, and then it's presenting the answer for that, coming from the model. So you don't have to do anything. You can squeeze it a little bit by providing extra synonyms, by providing pre-prepared questions if you want, but basically you don't have to do anything here. And then also always there's this link out there because the slides can be easily outdated. There's so many things happening on Power BI side. The insights feature was that we're asked for, please explain me the increase, decrease, and so on. That's what we have seen there. The smart narrative tries or puts the Q&A visual on the other way around, where we don't ask a question in natural language, but we get an explanation in natural language. And this is dependent, if you start these visuals, depending on what you currently see on the page. And of course, you can also add, or not of course, but you can also add your own text and your own like numbers, which are getting refreshed. So if somehow something in the filter changes, of course, then also these numbers are changing. So this is not hard-coded text, but it's reacting to filters and to refreshes. Analytic Line, I did show you the constant line with the 50%, and we discussed the trend line, the forecasting, and the anomalies. We did not have time to talk about the key influencer visual and also about the decomposition tree. So you have to check this out on your own. We have seen one smart custom visual for the ARIMA. It's just as a placeholder for many different things on the app source or marketplace. They're all constantly changing the name for the thing. It's always the same thing where you can download those visuals. You can also write your own visuals and load it directly into Power BI if you want. We did not talk about the what if parameter, which is not smart on its own, but it can make your measure smart, because the what if parameter allows you very easy to create three things like a slicer and a list of values and a measure which returns the selected value, and then you can react to that in your measures. For example, a what if scenario. So what if we increase the prices or decrease the prices? How would that influence the revenue and the profit of the company, for example? Then we talked about the R integration as a source, as a transformation, as a visual. I think we only discussed not directly about the source, but we can in Power Query have an R or Python script as a data source, which is slightly different from a transformation, because transformation gets data injected from Power Query. The source doesn't. It only exposes data to Power BI. This is true for R and Python as well. So it's up to your choice what you prefer here. The AI insights is something I did not demonstrate. Is as well in Power Query, where you can then run things and connect to cognitive services automatically if you possess a premium workspace. And of course, you could also do things directly connect to cognitive services and or machine learning services. on your own, and then you have to find out about where to find the API key and so on to connect this in Power Query. Couple examples, Smart Thing and Web Example, where you type in examples in Power Query, will then find out what you want to do here is next. So I think just before I run out of time, please let me know if there are any questions. And here are my contacts. So you can reach out, follow me on Twitter, add me on LinkedIn, and then we can take it from there. So thank you very much, and hope you enjoyed this talk. I hope you enjoy the rest of the conference.